Hi, this video will be going over the different conformations for butane. It's not specifically about butane, but that's the most commonly used molecule for testing your knowledge about the conformations and R and S configurations when it comes to this type of stuff. As you can see, all these molecules that I've drawn out are the exact same molecule with the exact same stereochemistry. This one would just be a line angle. This would be a Newman projection. So I'll write that out. Line angle and Newman. And this would be what's called a Fischer projection. These are all the exact same molecules. We can see that they all have R and S stereochemistry. RS, we would say that this front carbon has S, and the back one would have R. Now let's go about learning how we can draw these Newman projections in line angle conformations, because line angle is the most easy way to determine R and S. It's pretty difficult when you're given these Newman projections. It's very good to have a model kit. So right here, this is just a very simple model of the butane that I've drawn out on the screen. You can see when you're looking at it, these red dots would represent the deuterium molecules. These white ones would be the hydrogen, and finally the methyls on the bottom. Now if we wanted to put this in line angle, we could really easily see that if we turn it around, do something like this, right? We have this carbon right here going up to this carbon, which goes across to here, and then finally comes down. And you can see from your perspective, the deuterium are in the back, and the hydrogen, from your perspective, are in the front. Oh, excuse me, that's an H. And now from here, it's pretty easy to figure out what the stereochemistry is, the absolute stereochemistry. We know that we're supposed to put the lowest weight attachment in the back of the molecule, which would be H, because deuterium would have a weight of 2, while H's have a weight of 1. I've already determined this to be the S and R configuration. And you could check that yourself just by seeing that this is the number 1 priority group for this chiral carbon. And this would be our number 2 priority group, so 1, 2. The deuterium would be 3. And it looks like from 1 to 2 it would be in the clockwise direction, which would make it R, but our 4th priority group is in the front, so if we actually switched these two, we'd have to also switch the stereochemistry to make this an S, so it would really be in the anti-clockwise position. Moving on from there, Fischer projections are a really quick way to draw out molecules. Let's put some deuterium on there and H's. Now Fischer projections, we call it a bow tie, and that's simply because the lines going out horizontally are coming out at you. So it kind of makes this bow tie appearance. While the lines going over here are going downwards, okay? And for you looking at the camera, it would look something like this, where you have your deuterium on the side, and these are coming out towards you, and then your methyl groups in the back are going away from you. Okay, and so that's a very easy way to draw out Fischer projections. If you're thinking about MCAT, you put the most oxidized carbon at the very top. So let's say we had something like AC double bonded O, OH, CH2, C, D, H, something like that. We would put our most oxidized carbon at the very top. So our Fischer projection would look like this with our COO2, our 2 H's and finally our D and H. And that's about it for the various stereochemistries of butane. I'd really encourage you to read the book on this stuff and do lots of practice, because that's the only way to get it down. Having a model kit handy is also extremely helpful. I hope that helped.